5GA, give a little bit of background on V2X and why 5GA is very active nowadays on both short range and long range communication. Give examples of what kind of features and applications are supported by our members, and then look a little bit on different technologies that are specifically interesting to us. First, 5GA, it's an association. It brings together automotive and telecommunication industry. It's all about issues related to connected mobility, road safety, automated driving, traffic management, etc., etc. So it's at the end of the day all about connecting vehicles to different entities around it, whether it is in the cloud, whether it is in the edge, or whether it is just around the vehicle. So, and we call that V2X. So 5GA brings together 130 industry members from around the world to deal with all these aspects of V2X, which is a 3GPP supported standard, and look at technology, standards, spectrum, policy regulation, testing, security, and business model and go-to-market strategies. Here you see there are different priority areas. I'm trying to get rid of some of the things that are here. It's very annoying because I don't see the whole screen. And we have 8 priority areas, all rotating around interoperability and deployable and secure end-to-end connectivity solutions. So in the middle, you would say these are our vehicle manufacturers that are, and as well our mobile network operators that have different issues, and these issues are illustrated by the priority areas: security and privacy, integration with the road infrastructure and the traffic manager, making sure that the smart devices also deliver safety services, etc. Making sure that we increase our position accuracy, capitalize on what we have already, that means the cellular network with 4G and fast-track new mobility services 5G. Look at the benefits of cloud and edge computing, and as well make sure that we sustain the technology evolution along the different releases of 3GPP and other technology breakthrough. So now, who are our 130 members? We have more or less a good balance between the vehicle manufacturers, automotive industry and telecom industry, more or less 50-50. Among the vehicle manufacturers, we have 13 of the 15 global vehicle manufacturers. Among the MNOs, we have 9 of the top 10 mobile network operators, as well as the top 3 global smartphone vendors. So V2X is a very relatively easy, let's say, to understand, making sure that you connect to other vehicles with a short-range communication, also making sure that you connect with cyclists, pedestrians around you, roadside infrastructure, also with the roadside, with the short range. But very important, all these must be complemented and even done with always connectivity with the mobile network. Now, this being said, the short-range communication will still work without coverage, but the complementarity between the direct connectivity and the network-based connectivity is the essential part of the V2X. So as said, the direct communication is a device-to-device radio access technology. It's defined by 3GPP, and it's independent of the cellular network. It operates actually in the 5.9 gigahertz spectrum, which is more or less allocated all over the world for ITS applications. Now, I mentioned 3GPP a couple of times now. The 3GPP worked on LTE obviously since 2008. Since 2017-18, it really started to work on the 5G. But in the middle of all these releases between LTE and 5G, there was the release 14 that was published in 2017, which defined the LTE V2X, and especially the short-range communication of LTE V2X, which was then at that time seen as a competitor or to the DSRC IEEE 802.11p. So why did we come up with LTE V2X short range? That's because it was important in the 3GPP family to have a short range communication component. We at that time thought that LTE V2X short range would be taken as on board very rapidly, and then DSRC would be seen as the technology that was used for actually testing, but the real technology that is then used for actual deployment would have been LTE V2X. Well, since then, if you have followed a little bit, it has been a little bit of a conflict between IEEE standards on one side and 3GPP standards on the other side. And so it's let's say a relatively unfriendly and unconstructive relations between the two. We believe from 5GA obviously that 3GPP standards are the way to go. Why? Because all vehicles in the future will be connected with 4G and 5G. Therefore, the additional component which was competing with the SRC becomes obsolete because there is the LTE V2X short range. Okay, now there is LTE V2X short range since 2017, and NR V2X was just released as a new specification, and the two make it what we call 5G V2X, so what basically the holy grail at the end, and LTE V2X ensures basic safety, and NR V2X ensures advanced driving. Okay, I'd like to illustrate a little bit the complementarity on onboard sensors and V2I, V2V, and V2N. For a long time, this illustration has been there almost for 20 years since ADAS started to be implemented. And so the idea was that onboard sensors would help to act on the vehicle. The information coming from the network would help to inform, and in between you had a gap, and that gap could be fulfilled by V2V and V2I, which was helpful to mitigate the risk. Now what happened over the years is that onboard sensors really improved in quality and in price, and therefore competing a little bit with the short-range communication, and at the same time the technology that comes from the mobile network is getting more and more reliable and low latency, and therefore also competing with this V2V, V2I component, namely the short-range communication. Now, the vehicle manufacturers still want to exploit the 5.9 gigahertz and make sure that this 5.9 gigahertz is completely part of the combination onboard sensors connectivity to the network, as well as connectivity with other vehicles. Okay, I'll illustrate a few network-based communication. These things have been there for quite some time. Even perhaps if you don't necessarily know, obviously you may be already using your some mobile applications related to safety. But if you look at the connectivity inside the vehicles, it really started. The trend really started around 2015-2016 with the mobile or the radios embedded in the vehicles, which were actually detecting events, then sending this through the mobile network to a backend. This backend was filtering the data, aggregating the data, ensuring security and privacy, and also collecting additional information from the mobile work zones or from many traffic managers. And eventually, this information would then be sent to any vehicles that is in the vicinity if it's actually relevant to the driver, then it would appear on the dashboard. And so that was 2016 with the S-Class and E-Class, and 4 years after, all Mercedes-Benz vehicles, even the A-Class, have this integrated, and this kind of information flows all the time. And the great thing is that there is a scalability of these solutions, because it's really the same solution can be reproduced all over the world with almost the same kind of architecture. So back in 2016, the kind of hazard warnings that were displayed are listed here. It's all about either hazard related to other vehicles that may represent a hazard, accidents, broken down vehicle, anyone that has a hazard light, but also weather information, or also work zone information. A bit more complicated is the green light information. Why is that complicated? It's because it requires the urban operator, urban traffic manager, to give you some information, namely the signal phase and timing information of each at each intersection in each directions and each also topology. So it's relatively it can sound relatively easy when you look at an intersection, but it can get complicated. For some reason, it got deployed much faster in US, but it's at the moment expanding in Europe and China and other parts of the world. Why US is because the architecture around the whole US is relatively harmonized and uniform, and therefore was easier to reproduce the same architecture and the same system in different cities around US. And it's still at the moment we have about 35 US cities, which is not necessarily an incredible number, but if we look at the number of intersections, it's about 15,000 intersections, if I remember well. Okay, a bit more complicated even here is the connection to a police system, for example, or an emergency system where you need a standard. The police system is actually sending the information about a route, for example, for your ambulance. The ambulance then travels, and when a vehicle is in the trajectory of this ambulance, then there is the information displayed on the dashboard of the vehicle. So these are all systems that exist already, and further to that, what happened over the last few years, I wanted to illustrate it with a project that is called Nordic Way. This project is a safe project, so that means relatively close to actually introduction and deployment, so actually very close to deployment. And they have showed, this is just a subset of use cases, emergency vehicle warnings, geofence, more for managing environmentally friendly zones, dynamic access control, traffic signals, roadworks warning. I will just illustrate it with two and look at the architecture of these. And so for the emergency vehicle warning, exactly the same way as we looked for BMW, the same kind now has been implemented in Sweden, Norway, and Finland, if I remember well. So basically, the emergency vehicles uses its legacy network in order to communicate with its Swedish emergency agency. This is then communicated to another emergency network that is actually normally the one that is picking up the calls and then dispatching vehicles, etc. And then if you continue, it goes to another network, the vehicle mission monitoring institution, and the vehicle path prediction. So these are more or less new entities that are actually that have the capabilities of actuating, for example, some red lights, etc. And then it is then sent to all others via what we call an interchange node. It's a kind of neutral node that is collecting all information from many different sources and then distributing them to the relevant people. Okay. Now another example is the roadworks warning. It's a bit similar again. So it's a chain of information. There is a roadwork warning vehicle that is sending some information. It sends it through a node that is normally managed by the contractor or the traffic manager, and then the Nordic Way interchange node collects this information and then retransmits it to anyone that subscribes to this information along its route. So I'm not going to go too much into the details. Now I would like to spend, I still have a few minutes, like to spend some time on the direct communication aspect. So as I said, the direct communication uses the 5.9 gigahertz short range communication between vehicles or between the infrastructure. What is important here is that we see that there are overlaps between use cases that are implemented with V2N and use cases that can be implemented with PC5. So what happens is that you have two different information coming through different channels inside your vehicle. You have to make sense out of it. Perhaps you can fine-tune the information, and then you have to make only one warning appear to the driver eventually. So as examples is here the signal phase and timing. Also, instead of using the mobile network, what you do is to put an antenna sending the signal phase information directly from device to device to the vehicles. Now, it seems much simpler, but actually it's actually pretty more difficult to do. And the reason is basically that it is pretty hard to have a good interoperability between the different devices, and I will talk about it well right now actually. So over the last 2-3 years, since the standard definition, one year after the standard definition, we already started to demonstrate vehicles with V2X basic safety features in Washington, in Paris, in Berlin, and in Torino. So at each of these different events, we managed to implement more and more complicated use cases and also add some 5G enabled examples. Together with this, we had a full program of PlugFests. So PlugFests are interoperability events to make sure that you have cross-vendor, a good cross-vendor cooperation, and that you ensure interoperability between the devices. And so it's clear that when you have a device-to-device environment, it's much more subject to issues related to the definition of the standard or even the interpretation of the standard. So that's why you need much more of this kind of interoperability standard between the vendors. Traditionally, in a mobile network environment, what happens is that you have a device vendor that goes to a place to certify its device and does not necessarily need to do many different interoperability tests. But in this case, for device-to-device, you need to do that. So PlugFest back in Germany, in China. Also, we have done some virtual testing. So that's interesting because you don't necessarily need to meet face-to-face. You can use VPN network and then do the testing between each other from one place to the other around the world. And then we also support different partners. We have Etsy on one side in Germany, in Europe, INT 2020 Promotion Group in China, Omniair in US, etc., etc. So now what is important is that, and I mentioned earlier, is that there is always an evolution of the standards, release after releases. Sometimes it's very light, sometimes it's a quite important evolution. And I mentioned NR-V2X. NR-V2X now comes as a complement to the basic safety in LT-V2X, and it is being integrated together. Now, are you going to see 5G V2X vehicles right away? No, I think it takes 2 to 3 years between the definition of the standards until it is actually implemented in the vehicle. So we still have a few years where we are left with the LT-V2X, which is well tested and now ready for market. So when you add advanced driving features, what you get is a possibility to share sensors between the different vehicles and the infrastructure, better possibility to plan paths and agree on which path you're going to take, better resolutions in terms of maps and getting very dynamic maps information, and then also coordinated driving, a better way to do groups or platoons. I'm looking at the time. So very quickly, two big trends that I know these are trends around the world. I'm going to try to go fast. In US, Ford has been saying that they will equip all their new vehicles with C-V2X direct communication by beginning of 2022. In Virginia, Audi and Qualcomm have already started deploying green light information as well as roadworks information. In Georgia, we have large-scale deployment areas with more than 1,000 intersections with V2N, and actually there, that's interesting, it's a dual radio. That means that it's both supporting C-V2X short range and DSRC. In Texas, we have a replication that actually is done in Atlanta, so that shows that it's highly replicable and also scalable. We have, with CAMP, we have done a series of performance tests for CV2X. And then recently, over the last, let's say, 12 months, the FCC has been looking at the 5.9 gigahertz and actually revised the rules around the 5.9 gigahertz. It's both good and bad. It allows CV2X to operate in the 5.9 gigahertz, but at the same time, it gives a chunk of the band to the Wi-Fi operation. In Europe, OD has now introduced this signal phase information in different parts of Europe. BMW has announced the 5G, their first 5G cars by 2021. Continental has announced that they will supply 2 European vehicle manufacturers, we don't know which ones, with 5G V2X telematics unit, and et cetera, and so more on the regulatory front. The 5G spectrum auctions have now required in Germany that the coverage for 5G is with minimum 100 megabits per second by 2022 on the major network. So now for China, I would say China is the most proactive in terms of promotion of 5G and CV2X. They have nationwide plans for 40,000 kilometers of highway with 4G, 5G, and also coverage of roadside units in some hotspots. But also at the city level, they have 6 or 7 cities that have now embraced the deployment of roadside units at 5.9 gigahertz for short-range communication, especially for providing SPAT information, so signal phase and timing. Okay, I'm looking at the time, and then Korea, Japan, Australia are all looking at also obviously 5G, but also seeing how 5G is relevant for the connected vehicles. Okay, I'm not going to spend too much time. Perhaps it was specified before, but from our point of view, 5G has been looking specifically at the slice related to ultra-reliable low-latency communication. Network slicing is a very high-demand feature for the vehicle manufacturers. It allows for segmentation between different services on one side, for example, the broadband communication for the passengers, but also on the other side, at the same time, ultra-reliable low latency for other services. And that's a very appealing service for customers such as the vehicle manufacturers. I'd like to mention something that we took some time to specify is the in-advance quality of service notification. So in short, it means that you can predict what is the quality of service that you can expect in the next 100 meters or 1 kilometer, and therefore you can adapt your application with regards to this quality of service in the area where there is a degradation. And the second part of the aspect that we are looking at is the edge computing, especially making sure that edge computing provides or delivers service to all vehicles on the road. So that means that you need to make sure that there is a cross-MNO interoperability between the different vehicle manufacturers and service mobile network operators. And that's not always easy. There are standards for that, but it also requires a good cooperation between the operators in the country, which is not always the case. Now, on the short range, what is interesting in terms of 5G and NR-V2X is the possibility to actually address smaller groups, do groupcast, etc. And that's a feature that has been very much demanded by the vehicle manufacturers. So if you are interested, and I'll finish this the two last slides, we have published a use case roadmap very recently, perhaps a month ago. I show only one slide related to the roadmap. It starts with the services back in 2016, like I talked to you about, but then complemented with short-range communication and with a mass deployment that is starting in 2020, especially starting from China, but then eventually also being propagated in others. Now 5G, when the short-range communication is there, you can start to do all kinds of safety services, such as emergency brake lights and left turn assist. You can continue with interacting with vulnerable road users, and all the way when 5G V2X is there with cooperative maneuver and dynamic cooperative traffic flow. And that's the nice thing about the short-range communication. But at the same time, if you look at, there are plenty of different other use cases that will use also the long-range V2M communication. So I invite you to go and look at this roadmap. If you just send me a request, or you can also search for CV2X use case roadmap, and you will directly find it on our website. Okay, I will not go through too many conclusions. The main thing that I wanted to say is that it's already there. We have to exploit it. There is a huge momentum related to 5G. There is this direct communication that is very important for the vehicle manufacturers, that is being now launched in China. And there is a little bit of uncertainty related to DSRC, and so we're trying to clear this up via enabling regulations. And from our point of view, CV2X will only happen when we combine the two options with network-based communication and direct connectivity. Okay, that's it, 55. So I thought that I would be a bit shorter, but there was quite a lot of material. So, Tamer,
thank you, Maxime. Yeah, thank you very much. While we wait for any questions, I can first I would like to thank you and Jesus and Neeli for presenting, and I think it will be very helpful for all the young professionals. So my question from you, Maxime, would be that how you think the IEEE Vehicular Technology Society could support 5G so that we can bring this word on the VTS side.
Yeah, so it's IEEE is full of different groups, etc. And so it's not always easy to make the difference between the young professional group and then the standardization groups and the technical committee, also all the activities around publications, etc. What we find relatively sad is the attitude sometimes of some engineers that are that take it very personal, the competition between standards. So a lot of conflicts happen because of personal motivations, and I think as a young professional, it's very important to hear that at the end of the day, what we want is to have the best state-of-the-art technology. We don't want to have a 20-year-old technology for which we are going to spend millions to deploy on the road, and it's eventually not the right technology, and we fail to make sure that we deploy the right technology at the right time. So for DSRC example, it's a little bit sad. It was defined in 1998 as a vehicular technology, and then It took 10 years to just really make it to the first real serious work in terms of standardization of the upper layers, and then another 10 years of uncertainty, mainly because there was no business plan, business model, etc. Safety does not necessarily sell. There was uncertainty because there was a lot of unknowns related to who invests, etc., and eventually it led to nothing. So what 5G offers now is we know that 4G, 5G vehicles are coming to the market, and we make sure that there is a short-range component to it in the standard, so that no question asked, you just all the automotive chipsets that are going to be produced will have this short-range communication component, and therefore you have much less uncertainty in terms of implementation of these devices, of these kind of services.